When a switch is off, there is no constant amperage present. A switch in the off position creates an open circuit, effectively halting the flow of current. Consequently, the amperage measured at the switch would be 0. However, it is important to note that the wires connected to the switch might still carry residual voltage and potentially a small amount of current if other devices are connected downstream and drawing power. This residual current will almost certainly be far lower than the wire's maximum amperage rating. When a person experiences an electrical shock, both voltage and current play crucial roles. Voltage is the electrical potential difference, the force that pushes electrons through a conductor. Current, on the other hand, is the measure of the flow of those electrons. High voltage can overwhelm the body's natural resistance, allowing electricity to flow through it. Even relatively low currents can induce a significant shock if they traverse critical areas of the body, such as the heart or brain. The intensity of an electrical shock is determined by a combination of both voltage and current. The human body's resistance to electrical current varies depending on factors like skin dryness, contact area, and the path the current takes through the body. Dry skin offers higher resistance than wet skin. The path through the body greatly affects the severity. Current passing through the heart or brain is far more dangerous than current passing through an arm or leg. Generally, currents as low as 1 mA can be felt. Currents around 5 mA can cause a painful shock. Currents between 10 and 20 mA can lead to muscle contractions, making it difficult to release the source of the shock. Currents above 100 mA are typically lethal, potentially causing ventricular fibrillation, a disruption of the heart's rhythm. Electrical safety practices are critical to prevent electrical shocks. Firstly, always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is indeed de-energized. Secondly, use appropriate personal protective equipment, including insulated gloves and safety glasses. Thirdly, never work on electrical equipment in wet conditions. Water significantly reduces the body's resistance, increasing the risk of electric shock. Fourthly, be aware of your surroundings. Avoid contact with grounded objects when working on electrical circuits. Fifthly, use ground fault circuit interrupters, commonly known as GFCIs, in areas where water is present, such as bathrooms and kitchens. GFCIs quickly interrupt the circuit if they detect a ground fault, minimizing the risk of severe shock. Electrical codes, like the National Electrical Code, or NEC, provide detailed guidelines for safe electrical installations. The NEC covers various aspects of electrical work, including wiring methods, overcurrent protection, grounding, and equipment installation. Adhering to the NEC is essential for ensuring the safety of electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds a predetermined level. Fuses are one-time use devices that melt and break the circuit when the current exceeds their rating. Proper grounding is another crucial aspect of electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, causing the overcurrent protection device to trip. This helps to prevent electrical shock hazards. Electrical systems typically have two types of grounding. Firstly, equipment grounding, which connects the metal enclosures of electrical equipment to ground. Secondly, system grounding, which connects the neutral point of the electrical system to ground. Arc flash is a dangerous phenomenon that can occur when a short circuit creates a high-energy electrical arc. Arc flashes can generate intense heat, pressure waves, and flying debris, causing severe burns and other injuries. Arc flash hazard assessments are required to determine a level of risk and the appropriate personal protective equipment needed for working on energized equipment. Lockout-tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. These procedures involve isolating the equipment from its power source and placing a lock and tag on the disconnecting device. Only the person who placed the lock and tag is authorized to remove it. Regular electrical inspections are essential for identifying potential hazards and ensuring that electrical systems are in good working order. Inspections should be performed by qualified electrical inspectors. Electrical safety training is crucial for all workers who may be exposed to electrical hazards. Training should cover topics such as electrical safety practices, hazard recognition, and the use of personal protective equipment. Static electricity is a buildup of electrical charge on a surface. Static electricity can be generated by friction, such as rubbing a balloon on your hair. Static electricity can cause shocks, but these shocks are typically harmless because they involve very little current. Lightning is a powerful electrical discharge that occurs during thunderstorms. Lightning can cause serious injury or death. Seek shelter indoors during thunderstorms. Power surges are sudden increases in voltage that can damage electrical equipment. Surge protectors can help to protect equipment from power surges. Electrocution is death caused by electrical shock. Electrocution can occur when a person comes into contact with a live electrical conductor. The severity of an electrical shock depends on several factors, including the voltage, the current, the path of the current through the body, and the duration of the contact. Electrical burns can occur when electricity passes through the body. Electrical burns can be very deep and may require skin grafting. Muscle contractions can occur during an electrical shock. These contractions can be strong enough to cause broken bones or dislocations. Respiratory arrest can occur during an electrical shock if the current passes through the muscles that control breathing. Cardiac arrest can occur during an electrical shock if the current passes through the heart. First aid for electrical shock victims includes firstly calling for emergency medical assistance. Secondly, turning off the power source. Thirdly, checking for breathing and pulse. Fourthly, administering cardiopulmonary resuscitation or CPR if necessary. Electrical safety is everyone's responsibility. By following safe electrical practices, you can help to prevent electrical shocks and injuries. It is important to remember that electricity can be dangerous, even at low voltages. Always exercise caution when working with electricity. Consult a qualified electrician for any electrical work that you are not comfortable performing yourself. The NEC is updated every 3 years. It is important to stay up to date on the latest changes to the code. Many resources are available to help you learn about electrical safety. These resources include books, websites, and training courses. Take the time to educate yourself about electrical safety and protect yourself and others from electrical hazards. Electrical safety audits can help to identify potential hazards and ensure that electrical systems are in compliance with safety regulations. These audits should be performed by qualified electrical safety professionals. Infrared thermography can be used to detect hot spots in electrical equipment. Hot spots can indicate loose connections, overloaded circuits, or other problems that could lead to electrical fires. Ultrasonic testing can be used to detect electrical arcing. Arcing can indicate insulation breakdown or other problems that could lead to electrical failures. Ground resistance testing can be used to measure the resistance of the grounding system. A low resistance is essential for ensuring that fault current can flow back to the source and trip the overcurrent protection device. Insulation resistance testing, also known as mega testing, can be used to measure the resistance of the insulation on electrical conductors. A high resistance is essential for preventing current leakage and electrical shocks. Electrical safety programs should include regular training, inspections, and audits. These programs should be tailored to the specific hazards of the workplace. The goal of an electrical safety program is to create a safe working environment for all employees. Remember, understanding the relationship between voltage, current, and resistance is key to understanding electrical safety. Always respect electricity and follow safe work practices.